Hello everyone, I'm Shivpritham, presenting on behalf of Team Nimbus Nexus for Smart India Hackathon 2024 with the problem statement ID 1734 and title Downscaling of Satellite-Based Air Quality Map using AI/ML. So the problem that we are addressing to is the coarse data that we get from the satellites, which are not actually inferable and actionable. So we'll actually be giving our solution using AI model, which will be using machine learning, deep learning, and other image processing techniques to convert the course into highly accurate granular data, which is actually dependable and actionable. So this is the kind of course input that we actually get from Sentinel-5 data, which we have kind of improved it using our model, which is this one, using our prototype for the moment. We expect it to get much better, and this is the kind of data that we have got on the network. So it's clearly better than this, and we expect it to get it much better with time and give a much more granular and actionable data with time. So let's move on to the technical part of it. So using the flowchart, we can actually understand it that we'll be getting the data from the Google Earth Engine, and then we will have the cloud masking part over here. So the cloud masking part is actually done by the Google Earth Engine itself, so that's not much of a problem for us to be worrying about. So this is the kind of data that we actually get from Google Earth Engine after cloud masking. During monsoon, we have really high cloud covers, due to which satellites are not able to take proper data from the photos. So we actually mask it using white dots. Every pixel is a white dot over here, whichever is affected due to the clouds. So we'll be adjusting to it using our own processing model. So we'll be using pre-processing model, which will be using again AI/ML to be actually removing the noises and anomalies present in the maps. So that's the pre-processing part. Then it moves into the actual model, which will be using neural networks and convolutional neural networks for making the super resolution using deep learning techniques. So for this model, we have a CNN architecture ready, on which we are working on currently and training the model. So this is the kind of structure that we came up with. So this doesn't have max pooling and sharded convolution layer, which actually was leading to high memory usage and due to the loss of pixels during max pooling. So we are actually maintaining the size constant by using only convolution layers rather than max pooling, which actually works better in case of scaling the maps and other kind when keeping the data actually accurate rather than using other kind of stuff. So we use upsampling to actually increase the resolution at the last after 4 convolutions, and then we have a number of filters. So it's linked in the PPT, so you can go through it too. So after passing through the major CNN model, we will be actually checking the AQI data, validating it with the previous got responses. So that's the MVP of our entire project, which is that we are able to actually cross-check it with the actual AQI data present on the government websites, which are actually recorded from the government data centers, the air quality data centers. So that would be stored in the cloud storage for self-learning, so that the model gets better and better with much training, learning from its own mistakes. So after that, we format in the data and send the output image into the QGIS visualization, just so that it looks really good. So that we are actually giving a visually representable data, which is interpretable using different colors. So let me show you the quick glimpse of the prototype that we use. So, so moving on to the text2.py, we have the data over here. So this is the kind of the main code that actually gets the things running. So this is the input image that we have got. This is the normalized image, and this is the final image that we got after passing through several layers. And since it's not that inferable, so we'll actually go into the QGIS platform, which actually gives us a much better visually appealing data, so that we can actually filter out these things based on the number of, I mean, the level of the pixel color. So we'll be actually able to get the concentration of NO2 based on setting the colors. So I think that's really simple and understandable. So then moving back into the power presentation. So that's the core of the technical approach that so far discussed. Then we'll be using number of ML stacks and available libraries and other kind of things, so that we have the best kind of super resolution app ready for maps and satellite. We are actually making a constructive web platform where we'll be using different kind of data available already in the web platforms. So the Sentinel 5P satellite data is really dependable as from the Google Earth engine. That's a great thing. And we are taking the AQI data from Indian government websites for training and validations. So and other kind of free libraries that are actually available, and even AWS platform for handling the large data sets. So viability is really good because it's really cost efficient. We are not using any kind of paid things, and I think the computation part is also really easy because we are using mostly convolutional layer and avoided the max pooling as much as possible, so that the accuracy remains the same as it was before. So moving on, impact, as said before, the government agencies, researchers will have a great set of data where you'll be getting the data for every single pixel. So you can actually access every single village and get actionable data over it. And the government will be able to take actions if there's any outbreak of pollution or some kind of disaster. That's AQI level. Then this is the research and references, and which we have actually taken references to build our CNN model. So our model actually is currently at 4x to 6x kind of upscaling level. We expect it to go about 10x once we actually increase the number of layers. We expect ourselves to upgrade a number of upsampling layers, so to make it gradual upscaling so that it actually gets better and better with time. So we are working on that, and the considerable rates that we are looking forward to is using the CO2 maps, and also for PM 2.5 and PM 10, which actually India suffers a lot during the winters. For a time, we believe our solution had potential to make significant impact on public health and environment management. So uh, we consider our prototype to be really functional and ready to deploy kind of a website prototype, and we are working on it to make it better and better with time. We are also taking uh, inferences from general adversary networks to take the good things from it, although it has a lot of setbacks too. So we'll be actually taking the best of CNNs to actually address the given problem statement. So that's our problem statement. Thank you from our side, and I hope Nimbus Nexus gets to your heart.